Hi, in this video we're going to talk about perfect numbers and divisors, some examples and some strategies. So perfect number is the sum of its proper divisors. That's very mathy kind of talk. So let's translate it one step at a time. So this says a perfect number. We don't know what that is yet, but we know how to translate the word is. In math, the word is always translates to equals. Then it says the sum. Do you guys remember what sum is? S-U-M. It means add them all up. So we're going to be adding up some numbers. Then it says of its proper divisors. Divisors are numbers that divide into a number. So for example, the divisors of 15 are 1, 3, 5, and 15. A proper divisor, that's probably a new piece of language for you, is any divisor except the number itself. So the proper divisors of 15 are 1, 3, and 5. We leave off the 15. Okay, so now let's put this all together. Is 15 a perfect number? A perfect number, maybe 15, is, that's equals, the sum, that means to add them all up, of its proper divisors. That's 1, 3, and 5. So let's see, is 15 the sum of those proper divisors? So 15, is it equal to 1 plus 3 plus 5? No, we get 9 and not 15. So 15 is not a perfect number. How about 6? Is 6 a perfect number? Let's try it out. So we're going to start with, is 6 a perfect number? By getting the sum of its proper divisors. We're going to add up the proper divisors of 6. So right now, pause the video for a second and see if you can think of what the proper divisors of 6 are. That is, all the numbers that divide into 6, except not 6 itself. Pause the video here and try it out. So the proper divisors of 6 are 1, 2, and 3. We don't count the 6, and let's add them up. 1 plus 2 plus 3 is 6, so 6 is a perfect number. Now, how about a larger number like 60? We need to find all the divisors of 60 in order to see if 60 is a perfect number. So how would you do that? One way to find the divisors of 60 is to use a factor tree to find the prime factors, and then combine the prime factors to find the divisors. We can start the factor tree using any two divisors of 60 that pop into our head. So maybe we think 60 is 6 times 10. Great, we'll start with that. If that's not what you thought of that goes into 60, you can start with the two numbers you thought of, which I'll show you in a second. So let's say we start with 6 times 10. Here's 60. We branch out to saying 60 is 6 times 10. The 6 can still be broken down into 2 times 3. So we break it down into 2 times 3. And the 10 can still be broken down into 2 times 5. Now, I made those numbers orange because the 2, the 3, the 2, and the 5 are all prime. So we stop there. 60 is 2 times 3 times 2 times 5. Or if you want to, you can reorder it 2 times 2 times 3 times 5. Those are the prime factors of 60. Now, what if you started the factor tree like this? 60 is 3 times 20. That's fine too. Now, don't think that this means you have to do the factor tree 2 different ways. I'm just showing you if you started it in a different way, you will still come up with the same factors. So I made 3 be orange just to show you stop at 3 because it's prime. But 20 can still be broken down. Maybe you think 20 is 2 times 10. Or maybe you thought it's 4 times 5. Doesn't matter. It works either way. The 2 is prime, so we stop. but the 10 can still be broken down into 2 times 5. And now all our prime numbers are the 3, the 2, the 2, the 5. So here's our prime factorization. It's in a slightly different order, but it's the same prime factorization, no matter how you start your tree. Now let's turn the prime factors into the divisors, because the prime factors are not the same as all the divisors of 60. We know 60 is divisible by 2. That's one of the divisors. To get the other one, you could divide 60 by 2. Now we have 2 of the factors, 2 and 30, because 60 divided by 2 is 30. Now look at your list of numbers there. We can also see that 60 is divisible by 3. That's another one of the numbers in our list. Now 60 divided by 3 is 20, so now we have 2 more factors, 3 and 20. And we know 60 is divisible by 5. So we divide it by 5 and get 12, and that gives us another 2 factors. Now, we also see that we have 2 times 2 in there, which is 4. So we know that 60 is divisible by 4. Divide it by 4 and we get 15. Gives us another 2 more factors. We can also combine the 2 and the 3 here to get 6. So 60 is divisible by 6, giving us factors of 6 and 10, right? 60 divided by 6 is 10. And finally, we try the 2 times 5, but we already got that. That's over here, this 2 here and this 5 here. And we already also have the 3 times 5. We could also check for combinations of 3 factors, like here, 2 times 2 times 3, but we already got all of those when we divided by the remaining factor from before. But you could still check them if you like. So finally, here they are. Here are all the divisors of 60. The 2, the 30, the 3, the 20, the 5, the 12, the 4, 15, 6, 10, and of course 1 and 60. If we put the proper factors in order, you have your factors of 60 from 1 up to 30. You don't have to put them in order though. What we're now going to do is see if we add them up. Do we get 60? Is 60 perfect? So let's add them up. When we add those numbers all up, we get 108. So we don't get 60. So 60 is not a perfect number. So that's generally the way to use a factor tree to try to find all the factors, and then from the prime factors to find the divisors. Just remember, prime factors and divisors are not the same thing. If you have other ways that you like to try to find all the factors of a number, that's fine too. But I want you to give the factor tree a try and see if it helps you get organized with what the divisors are.